Greencap are experts in the management of people, property and environmental risk. We help clients with practical solutions to their problems every single day. So that is really what we do and is at the heart of what we do. Greencap offers a breadth of risk management solutions under the one roof, including expert services, training and online solutions. Greencap first started in 1984. It wasn't known as Greencap back then. It was known as Noel Arnold and Associates. The reason the business existed then is the concerns around asbestos started to become real. Greencap found a niche or found a space. The business really grew from there, taking on additional facets of risk management, including occupational hygiene, work health and safety, and emergency management. Greencap operates across a broad range of industries, including construction, infrastructure, retail, wholesale, government, not-for-profits, and both big and small. We deal with thousands of clients and work on hundreds of thousands of projects. So it could be anything from the big end of town to small businesses that are facing significant problems. I think it's the way we work with our clients in terms of we work side by side with them. It's the way that we are able to bring a team together from right across Australia and New Zealand. It's the depth of our expertise. It's really our people that make our business. So we have 10 offices across Australia and New Zealand, and we have over 300 people. An important part of what we do is to share our knowledge. We do that in a number of ways, by working directly with our client on a project or an assignment. We can do that by sharing risk reviews. We also have, across ANZ, breakfast seminars where we share that information, and we produce white papers. Our people really care deeply about clients and professional development. The culture that we have is really about that professionalism, focus on clients, care for each other, and care for what we do. And what we see as a real hallmark of success is getting Greencap involved early up front to plan the project, and we get the best results that way. Greencap is accredited by NADA and IONS in New Zealand for our laboratories. Our on-site labs are also NADA accredited, and uniquely we also have a on-site, or what we call as our lab in a van, which offers that service in a mobile fashion. On top of that, our management systems are also accredited to ISO 9001. We believe we put our clients first. Greencap measures client satisfaction of our projects, and we are committed to continuous improvement in our service delivery and client satisfaction. Client first is an ingrained trait at Greencap. Integrity to me is doing the right thing, even when no one's watching. We want to make the world a safer place, and we believe we can make a meaningful impact. Our clients want to do the right thing, and they're operating in a complex and regulated world. Greencap exists to make the world safer, and that resonates with our team, and that's why they're here.
Good afternoon and welcome to our CCF Masterclass, the new Silica Regulations. My name is Jeff Reynolds. I'm the HSEQ representative for the Civil Contractors Federation, and I'll be facilitating the webinar today. Before we continue, I'd like to acknowledge the traditional owners of the country throughout Australia and recognise their continuing connection to land, waters and culture, and we pay our respects to their elders, past, present and emerging. Today's webinar will be an informative session with speakers from OH&S and risk experts, Greencap, and our friends at WorkSafe Victoria, who will discuss the dangers of working around crystalline silica and precautions that the civil construction and demolition industry can take to reduce associated risks. In other words, what you most need to know on how to reduce risk. Crystalline silica is a natural mineral found in construction materials such as concrete, bricks, tiles, mortar, and of course engineered stone. Exposure to crystalline silica dust over a long period of time at low or moderate levels or short periods at high levels can lead to serious health conditions such as silicosis, which is an irreversible, incurable and progressive lung disease. It can lead to disability and death. Construction and demolition employees can be at risk of developing this disease. Finally, I'd like to acknowledge our business partners for the event, Gallagher and Greencap, and we'd also like to thank them for their continuous support of CCF Victoria. Our first speaker is James Webster, Program Officer, Technical Inspector at WorkSafe Victoria. Prior to joining WorkSafe, James was a grade A electrician, so he in fact has come from the trades. He is now a construction inspector, technical inspector and program officer, and he's in the process of completing his Bachelor's of Public Health and Health Promotion at Deakin University. This has helped him in his role as program officer within the strategy team and has assisted in the development of the Priority Harms project. Silica, of course, is now one of the priority harms listed. James will discuss the regulations, compliance code, and cover a little bit on the WorkSafe Priority Harms program and the civil subsector, including chronological overview of the new Crystalline Silica Regulations. Let's welcome James.
Thanks, Jeff, and it's nice to be here, and welcome to all the members who have joined us today. I'll just share my screen. No problem. So what I will do, we'll kick it off with the Priority Harms program. We'll then move on to the new regulations and what they mean, and then we'll have time at the end for Q&A discussions. So the Priority Harms program, so what is it? We developed this Priority Harms program to focus on the most prevalent causes of harm within 4 subsectors, being commercial, demolition, housing, and civil, and it runs for around 12 months. So throughout this program, inspectors will be visiting workplaces and will be inquiring into those prevalent causes of harm within each subsector. They all differ, but in civil, we'll be looking at falls from heights, electricity, falling objects, moving plant, trenching, and of course, first of all, crystalline silica. So talking about crystalline silica, so what is it? So a bit later, Jason and Julie will go into the science behind how abrasible crystalline silica can damage our lungs. So we'll leave that there. But for now, let's just understand that if we do breathe in these fine particles which contain crystalline silica, it can impact our lungs and can cause silicosis. So here's a list of some common substances which contain crystalline silica in varying proportions. In its solid form, there is no risk associated with inhalation, but it's when we start to process these substances and turn these substances into fine particles and we breathe them in, that's when that does do damage to our lungs. A bit of a tip as well, you may hear crystalline silica be referred to as quartz. The terms are interchangeable. So if you hear a mate at work say, yeah, this product's got quartz in it, or if you refer to a safety data sheet and it speaks of the product containing quartz, you know that this product contains crystalline silica. So what are the new regulations? So the amendments to the Occupational Health and Safety Regulations have come into place to provide greater protection to the Victorian construction workers and quarrying workers and tunnelling workers who work with crystalline silica products. These regulations have been introduced over 3 stages. The first stage being in November 2021, and that was the licensing applications for those businesses who work with engineered stone. It also introduced specific control measures for working with that engineered stone. The second stage came about in May 2022, and that saw the introduction of crystalline silica processes and high-risk crystalline silica work. It also introduced manufacturer and supplier duties. In November 2022, businesses who work with engineered stone must be licensed, and suppliers of engineered stone must only supply engineered stone to licensed businesses. I think at this point it's important to mention that these regulations are largely administrative based and they're there to complement the existing sections of the Act and the regulations, meaning how we've controlled the risk out on site, whether it's misting units, foggers, dust extraction methods, PPE, that all remains the same. This is largely administrative. So I think it's best to go over these regulations from a chronological perspective. That is how you would apply them. So let's imagine a scenario whereby we're hiring a new worker to create a paved footpath, which would involve the cutting of these pavers. We'll follow the worker from the application stage through to performing the works. So during this application phase, we would need to inform this potential worker that they may be required to perform high-risk crystalline silica work. We need to inform them of the risks to their health and what control measures are used to control that risk. This may include the need to be clean shaven. Because this worker absolutely aced the interview, we've decided to hire them. So now we've got to train this worker up. We'll need to tell them all about the health risks, those control measures, and how to use them. So this is no different to any other risk in our workplace where we provide information, instruction, and training. It's just silica related now. So this worker has gone out to site. They've just received a pallet of pavers from a particular supplier. And that brings me now to the manufacturer and supplier duties. So when we talk about this, we talk about a crystalline silica substance, which means a product or a substance that contains more than 1% crystalline silica is reasonably likely to be mechanically processed at the workplace, and it's not in respirable form, so it may be wet or it may be solid, such as a paver. So in these circumstances, manufacturers and suppliers of these products must give information regarding the proportion of crystalline silica, and that will be expressed as a percentage. It must include the name and address and telephone of the manufacturer or that supplier, include exposure controls, exposure standards, engineering controls, and personal protective information. It will also include handling and storage of substances. And as you can see, it's not too dissimilar from an SDS or a safety data sheet. And the reason why we've included this is with products that contain crystalline silica that is respirable, such as grout or cement, they already have this safety data sheet. So this is a stopgap, as you will, just to fill in the rest of those products in the market which do contain crystalline silica and can cause a risk to health. So we talked before about crystalline silica processes. So it's important to know that this is going to be foundational, and it will build upon these high-risk crystalline silica works in later slides. So there's about 6 of them, and I'll go into detail now. So a crystalline silica process consists of one or more of the following processes being carried out at a workplace. So A, the use of a power tool or other form of mechanical plant to cut, grind, polish, or crush material containing crystalline silica. Or 2, carry out any other activity involving material containing crystalline silica that generates crystalline silica dust. So this is a pretty broad regulation, and the chances are it's likely to apply to your workplace. So if we're thinking about this worker, they're going to be cutting into a paver which contains crystalline silica, and therefore it will be deemed a crystalline silica process. If we're thinking about someone out in the field with an excavator, hammering through some sort of rock which contains crystalline silica, and that creates dust, again, this will be captured in sub-regulation A. B talks about the use of a road header on an excavated face if that face contains crystalline silica. So we may think of quarrying sites, we may think of tunneling sites who would use road headers in their day-to-day activities. So there they are 2. Moving on to the 3rd, a process that exposes a person to crystalline silica dust arising from the manufacture or the handling of a material that contains crystalline silica. I'm not too sure of the makeup of this crowd and whether you guys manufacture particular products, but I think the second point here being the handling of material, probably be most relevant to this particular crowd. So when we think about this, if we think about a worker who is perhaps mixing some grout in a bucket, tipping that grout into the bucket will be considered the handling of that material. Similarly, we can think about dry sweeping out on site. So if there's say, for example, concrete dust on the floor. This particular worker dry sweeps it into a pile, scoops up and puts it into a bin. That would be deemed handling of material that contains crystalline silica and therefore a crystalline silica process. Moving on to D, so the mechanical screening of crushed material containing crystalline silica. So I would think of something like this being a large greenfield site whereby a contractor would dig up a lot of rock, providing that rock contains crystalline silica, and they crush it and screen it into various aggregate sizes. So that may be captured under sub-regulation D. We can also think about the recycled material industry. We know there's a lot of, we know that's a burgeoning industry. There's a lot of pressure on that industry to grow, and that could be captured here with sub-regulation D. Moving on now to E, so a quarrying process involving material containing crystalline silica. It's quite self-explanatory. If you're quarrying in a material that contains crystalline silica, it will be deemed a crystalline silica process. And of course, we have F, a tunneling process involving material containing crystalline silica. So I said before that we have a road header, and a road header can be used in tunneling, but it's important to call out that while a road header can be used in tunneling, tunneling doesn't always involve a road header. So that's why I've included it in here. And then we've got G, a pretty ominous sub-regulation. So a process determined by the authority, WorkSafe, under Regulation 6 to be a crystalline silica process. As far as I'm aware, there has been no processes determined by us as of yet outside of those 6 processes to be a process. I said process a lot. I hope you kept up. But yeah, there has been nothing, and I do imagine it will be quite a process to go through that and deem that to be a crystalline silica process. I'll try not to say process for the rest of the slides. Okay, so this worker, we know that they're cutting into pavers and it's going to be a crystalline silica process. We talked about a high-risk crystalline silica work, and that is any crystalline silica process that is likely to result in an airborne concentration of respirable crystalline silica that exceeds half the exposure standard for respirable crystalline silica. And that is, the exposure standard is 0.05 milligrams per meters cubed. It's easy to remember. It's the same as our blood alcohol limit for when we drive a car. So half of that is 0.025 milligrams per meters cubed. And that is quite a low threshold. So you can imagine a lot of these crystalline silica processes are going to be captured as high-risk crystalline silica work. We also have here a risk to health of a person at the workplace. But I do imagine that first point, an airborne concentration that exceeds half the exposure standard, being the lower threshold of the two. So it's great. We know this work is going to be performing high-risk crystalline silica work. But let's just go for a scenario where we don't think they're going to be performing high-risk crystalline silica work, hypothetically. So what will we need to do? So in those scenarios where we don't think it's going to be high-risk crystalline silica work, we need to do a risk assessment, and that would be to prove that it's not. This risk assessment must take into account the task or the processes required to be undertaken with that material, the form of crystalline silica, the proportion of crystalline silica in that material, the likely frequency or duration, any information at your workplace about incidents, illnesses, diseases associated with exposure to crystalline silica dust at that workplace. And this is an important point. The risk assessment can't take into account risk control measures that we've implemented in Regulation 163. Put simply, for example, if we are drilling into concrete and we use an M-class or a H-class vacuum, this risk assessment must pretend that that vacuum is not there. It's uncontrolled. So that's a really important point. I just wanted to call that out here. So if at the end of this risk assessment, you're scratching your head, you're thinking, is it or is it not? Can't determine it to be high-risk crystalline silica work. It's got to be deemed high-risk crystalline silica work. So it's got to be conservative in that approach. So hazard control statements. So these are for high-risk crystalline silica works. So a hazard control statement is required to perform that high-risk crystalline silica work. It must state the hazards and risks associated with that work, sufficiently describe the risk control measures and how they're implemented, include analysis of material, whether you're tunneling or quarrying, and it must be set out and expressed in a way that is readily accessible and comprehensible. It must be reviewed and, if necessary, revised if that work changes or if there's an indication that those risk control measures are inadequate, such as an incident, for example. I would assume that a lot of the members here would have SWIMs in place, which would capture a lot of high-risk construction work, and we recognise that. So what we're saying is, if you have a SWIMs in place already at your workplace, you can incorporate these silica controls into your SWIMs, and that's sufficient. And as you can see, these requirements for a hazard control statement is not too dissimilar from a SWIMS, so it should be familiar to everyone here. So though this is not strictly in the chronological order, I did want to include this. So if we did think about where this regulation would apply, this would be at the planning stage. So if a high-risk crystalline silica work involves a quarrying or a tunneling process, an employer or self-employed person must, before that work commences, collect samples of materials to be used in the quarrying or tunneling process and arrange for the analysis of those samples by a suitably competent person to identify the proportion of crystalline silica contained in each sample. So like I said, this would be in the planning stage. So when we're engaging our geotechs to go out and do some analysis of what we're going to be tunneling or quarrying through. I've included here some other things to consider, and these are outside of these new crystalline silica regulations. So when we're implementing risk control measures, we must implement them following the hierarchy of control, meaning we should be looking for those engineering or substitution or elimination type controls. If you're unsure of the levels of exposure, conduct some atmospheric monitoring. Greencap, for example, can come out and conduct this atmospheric monitoring to let you know how much dust you are generating. And here's an important point as well. Employers must ensure health monitoring is carried out for an employee if exposure to crystalline silica is reasonably likely to have an adverse effect on the employee's health. So if we're going above the exposure standard, we ask that you send your employees off for health monitoring, get their lungs x-rayed and understand if there is any damage to the employee's lungs. Here's some guidance. We'll also publish this on the Greencap website. All these guidance material is available as well on our website. And yeah, thank you very much for your time today. Really appreciate it.
Thank you, James. That's an interesting presentation. And I think what I've taken out of that is that if you do a risk assessment on whether you have silica in your work site and you can't absolutely answer that it's not there, then in fact you should deem that it is there. Now everyone will have a lot of questions coming out of that presentation. We have provided a mechanism, the chat function of Teams on the sidebar there. If you're not familiar with how to get to that, there's a chat token on the top bar. Click on that and you'll be in chat. Simply type your questions regarding James' presentation and as we go through about Greencap's presentation. And at the end of the Greencap presentation, we will go through those questions and provide some answers, especially to the serious ones. During the Greencap presentation, we're also expecting to run a couple of polls. They'll come up on the screen. We'd like you to answer those polls and that'll provide material for the ongoing presentation. And at that point, we'll welcome Greencap to present, and we're going to have Jason Green and Julie Sullivan. Jason is has over 28 years experience in the field of occupational hygiene, indoor air and environmental air quality, chemical exposure, hazardous materials, workplace health and safety, and environmental consulting. He's conducted a diverse range of occupational hygiene, IAQ, IEQ risk assessments for a wide range of government, commercial, residential, industrial and construction projects. He's been the lead occupational hygienist on multiple large construction and infrastructure projects in Sydney, New South Wales, where respirable crystalline silica has been a huge focus. He's played a pivotal role in preventing worker illness and diseases with many engineered stonemason manufacturing and other silica-related and focused industries, as well as being an advisor to the National Government Silica-related Strategy and Action Plan. A fairly scary level of qualification, you'd have to admit. Julie Sullivan is also a certified industrial hygienist. She's from Canada, has over 25 years experience in the field of occupational hygiene and hazardous materials. She has moved to Australia with her husband, fallen in love, and I believe is now going to become an Aussie. With her chemistry background, Julie has conducted hundreds of occupational hygiene risk assessments dealing with toxic materials such as lead, ammonia, crystalline silica, isocyanates, and clandestine laboratories and more. I'm not sure what's in a clandestine laboratory. She served as a medic in the Canadian Naval Reserve and has found the training useful for infection control projects in hospitals and healthcare environments. A passionate believer that education is the key to worker safety, and Julie has developed and presented thousands of bespoke courses ranging from 1 hour toolbox talks to 2-day-long hazmat courses. Sounds to me like there's a bit of experience there we'd all like to get access to. So let's welcome Jason Green and Julie Sullivan.
Awesome. Thanks so much, Jeff. Yeah, really excited to get into silica and with all your members. So I'll just share my screen here. You can see my screen there now. So we're going to go through, with the short time we've got with you now, go through the risks around crystalline silica and have a look at the controls. So these are some of the things that we're going to cover off. We're going to start with an opening poll, so get ready there. Julie's going to step you through and have a bit of a look at what is crystalline silica, where is it encountered, and then we're going to have a look at some scenarios and case studies. So I'm sure there'll be something there that you've done before or have seen done before. So we want to have a look at the hierarchy of control as well, which is, as you know, very important in this discussion. Then we're going to have a closing poll and then a summary for questions. All right, so we'll just jump into our first poll here. So hopefully that will come up on the screen there for everyone to answer. So the question is, do you think your workplace and the activities that you're doing there would be classified as a high-risk crystalline silica work type process? So that poll's up there. So you've got three options there. So essentially you've got yes, we've identified activities, you've done a risk assessment, you've got controls in place, things like that. No, RCS risks are not applicable in your operations. And then the last one is unsure. You don't know. You hopefully you're here today to find a little bit more information around that. So looks like we're just about all there, I reckon. So I think it's a vast majority of vast majority, I suppose it's just a majority really of yes. So people on this webinar have got silica in their workplace and in their work activities. So that's interesting. And then we got a few that said no there, which is good. You're getting information there. And then it was a few there was unsure as well. So so we'll move it along, and I'll hand it over to Julie, who's going to take you through the next section.
So you may have heard that crystalline silica is the new asbestos, and actually it's probably the old asbestos. Unlike asbestos, we can't ban silica. It's in so many things around us. And for example, it's at the beach. It's in the sand at the beach. You can't ban going to the beach. And sand creates, various amounts of crystalline silica. I may address that a little bit later because you're probably thinking now, oh my God, I can't go to the beach anymore. Not quite. But silica, when we talk about crystalline silica, it's basically a combination of two elements, silicon and oxygen, which are very abundant in the Earth's crust. So it's around us all over the place. So a lot more abundant, again, than asbestos. Now, we are really more concerned about respirable crystalline silica, or RCS. There's other types, amorphous, like non-crystalline forms, like in my glass of water there, The glass itself is amorphous silica, not the same health effect. So the crystalline part refers to the shape the silicon dioxide takes when it's formed. And like James and Jeff said, it's most commonly seen as quartz, like the one on the slide there. And there's two other crystalline forms, cristabalite and tritomite, but those are much more rare. Again, like James mentioned, if it's intact and hey, if it's in that big crystalline form on your desk, it's not going to cause you any harm. However, we use power tools to cut it, grind it, abrade it, or otherwise fracture it, and we can release those crystalline silica particles that we can breathe in very easily. Now, it's the smaller ones that you can't see that really get you. We can see with our unaided eye around 10 microns at the smallest. And that's, we see the dust particles shimmering in the sunlight there coming through the window, reminding you have to do some housekeeping. Smaller than that, get deeper down into our lungs. And you can see in the middle pictures there, those are just little screen snapshots courtesy of WorkSafe BC, which is where I'm from, in BC. And you can see how those crystals just bypass, the small ones just bypass all our respiratory protection, the cilia, the mucus, whatever, and they go deep down into the lungs. Now, all dust, especially inorganic and insoluble types of dust, are not good for our lungs. They're designed to handle gases only, preferably oxygen. So those little crystals can scar up our sensitive lung tissue, and those little macrophages, that's what's showing in the bottom picture there, sent to clean them up, die in trying to do so and leave scar tissue behind. Hopefully not as bad as the lungs on the right there, which are basically about some poor mine worker who has silicosis and tuberculosis. Now, breathing it in cause serious health effects that cause irreversible lung damage, obviously. You've probably heard about silicosis and obviously lung cancer. Other respiratory diseases it causes are like COPD, emphysema, bronchitis, but it also is being associated with autoimmune diseases such as rheumatoid arthritis, scleroderma, and kidney diseases. It's irreversible, but with some awareness and controls, fully preventable. So like this slide is showing here, it's around us everywhere. At the beach, by the way, because the particles are quite big, they don't count as, they're about 10 times bigger than the respirable type of crystalline silica that we're dealing with. So we can generally capture them in our upper respiratory system and not inhale them down deep into our lungs. Also, beach sand has been rubbing against other little beach sands, and those sharp edges on the crystalline form that it takes are sheared off and softened, basically. So it's not the same harsh crystal that you get from freshly cut crystalline silica. So, but it's everywhere. Sandstone, if you didn't know, sandstone contains around 70 to 90% crystalline silica, and it was actually caused a disease back in the late 1800s, 1900s, when they were building the sewage tunnel in Sydney. The workers started to develop silicosis, but they called it sewers miners disease then. And because they were cutting through Hawkesbury sandstone, which is around 75% crystalline silica. So at the top end, there's a reconstituted stone, but basically concrete, brick, marble, ceramic tiles, you name it. If it's got sand as part of it, or ceramic, what's another one you use here? A lot of cement board, right? That's a very common one. So, and it's all those soil, etc. Now, we just stuck this in here because it's just good to remember that although we've got, to be very careful about our health and safety at work, and we got to be careful about, falling off buildings, dropping things, etc. All those, those kind of health and safety instances, those are dwarfed by the amount of people that are getting sick every year and succumbing to illnesses and disease while they're just doing their job. Diseases such as silicosis, 8 times basically more workers. So on the next slide there, Jeff, or I think James mentioned that there's an exposure limit of 0.05 milligrams per meters cubed for respirable crystalline silica. So that's a number that we could determine when we're doing sampling, atmospheric sampling, while your workers are doing their activities. And to give you an idea of what that would look like, if a person was exposed to just at the exposure limit, 0.05, and that was for 8 hours a day, that little pile of, that little dust speck there next to the tents, thank you, Jason, that is basically all you need to inhale in the whole day for you to be exceeding the exposure standard. So now bear in mind, the action level, or 50% of that, is half that amount, right? So now maybe if the 9%, if you're thinking, gosh, well, I may do a couple of cuts, but I don't think I'm exposing myself over that action level, it may be not the case. And of course, that's also for 8 hours, right? If you're dealing with a longer shift than that, we have to adjust that down. And so if you are at the action level, that's when you have to get your high risk crystalline silica work risk assessment and develop that crystalline silica hazard control statement, like James is saying. Thanks, Jason. All right, so let's, before we get into the scenarios, it's really critical that we just don't jump to PPE when we're trying to protect our workers or ourselves against silica. And we want to go through this hierarchy of controls. And it's actually even designed to show that, you know, going at the top there, that's the most successful, that's the most effective way of controlling that a worker's hazard. Through elimination or substitution. Obviously, you can't eliminate the crystalline silica at work, most likely because it's part of your concrete, it's part of the building materials. Right now, it's just very heavily used. So get rid of that one. Substitution, sure, we could go to lower concentrations of silica. That's definitely a good way to go. But we couldn't really completely substitute it right now with our current materials. The next one is going to be isolating the worker from the hazard, either with physical barriers or through dust capturing tools so that it sucks up that dust. And then go into administrative controls, which is basically what the this new Safe Harm or this program is about. It's basically the administrative controls, including safe work procedures and critically worker training and monitoring to make sure that these people have early identification if they are experiencing any troubles. And then finally, then you can get to PPE if you still can't control the silica adequately. That's when we grab the PPE. Let's face it though, in reality, it's usually the first thing that people grab. All right, thanks. All right, so this is a one scenario that I dealt with back in Canada that we were called in because our Safe Work Victoria or Safe Work BC had to shut down a job. What was happening is they were just doing some removal of some tiles around a pool, and the workers were there just jackhammering. They were just working for a little while, and it didn't take long before complaints were mentioned in the building because they were jackhammering near an air intake. And you can see the picture in the bottom middle there of what's happening to the air intake. So through the returns going into the HVAC system, it was being redistributed around to everybody in the office. They started to notice that there's dust developing on their desk. They felt like their throat was getting dry and scratchy, and reported to their supervisor, who did an investigation, saw what was going on, called in the Safe Work. They shut down the job, tools were put down, and we came in and we did some sampling. Now, even after, by the time we got down there, tools were down for about 3 hours, and then we did, 6 hours of sampling, and even then, the exposure standard was exceeded. So we didn't even see visible dust there, but just a little bit of a haze. And so, like again, I said, it's the dust you can't see, the really small bits that can stay airborne for a long time. Another scenario similar to that, but was with a person who was cutting out some concrete floor, cutting through those ceramic tiles and into the concrete floor in a bathroom. Now, they'd only been using that for, 30 minutes before they shut down that work. And they were actually trying to suppress the dust by using water. A lot of these tools already come with water, right? Which is great because it helps keep the tool cool, but it also helps suppress that dust. The really critical thing is, though, to make sure that slurry that's generated is cleaned up before it dries up and gets airborne. But anyway, after 30 minutes only and no other work done that day, this person exceeded 2 to 3 times over the workplace exposure standard after 30 minutes. So was that hose appropriate? Was it giving enough flow? Because that's the thing, there's a certain amount of flow you have to have, right, for it to adequately do its job. Or if you're talking about dust extraction tools, they have to be adequately maintained. And you can't just rely that they're working fine, if you haven't changed the filter for 3 years. And then finally, another process or handling of concrete was a real simple one. They were bagging some cementitious premix in the just in that little bag there. And the person who was doing the bag was just constantly being exposed to this little puff of dust that was coming from it. Just imagine like you're filling a bag of flour, same idea, right? Just dumped in there, a little poof of dust came out, and it basically exceeded by 4 times his exposure standard during the day. So you can see you can probably think of ways you can control the dust that's generated under these activities, right? Maybe you have to create a little isolation booth or something, some sort of containment for this kind of process, or a better extraction hood or something. But if you go to the next slide, yeah, we'll talk about what kind of things we would recommend for those situations. If you can't isolate the worker, can you isolate the area? For example, for the pool tile, they should have had barriers up. They should have protected the air return so that the HVAC system was kept clean. They could have had someone on water while they're doing the actual jackhammering, and not just gushing at it with a hose. Jason will show you how it's much more effective when you have just a fine mist in his part. So worksite barriers, enclosures, local dust ventilation. Gosh, those tools like that one on the left there, that's an awesome one. You can get that in Australia here for about I think $90. You just attach it to your H-class vacuum and it stays sucked up to the wall. And so if you want to drill in to like a cement board or anything that's going to generate dust, here they've adapted it so that they can use it for a drywall saw. Whatever, you can do it for coring, repeat it. We use it over and over again, and it just captures that tool, and you don't have to hold on to it when the vacuum's on. It's awesome. You can also get them with the wet coring idea, like you can see on the right-hand side. And then finally, yeah, that's the thing too. Vacuums are so critical. We can't use a shop vac for this. Shop vacs are just going to let that dust go through the filter and out into the breathable zone again, and it'll stay airborne for a long time. So make sure that you've got a good quality vacuum and that it's industrial. I would prefer to see an H-class vacuum. I know it says M is okay, but H-class is better. All right, and now Jason's going to take you through another scenario.
All right, thanks, Julie. So yeah, excavations. So I mean, I'm sure that's very relevant to quite a lot of the people on the call today. So we'll just have a quick look at some of these sort of situations, and these photos are no doubt quite familiar, whether they're using loaders or diggers or hammers or whatever they're doing. They're essentially aggressively removing material, either using saws, using all sorts of implements to essentially break the material or move or retransport the material into other parts of the site. So I mean, there's a lot of different ways that dust can be airborne into these situations, and I suppose, as you can see in these photos, you know, there's people working in these pieces of equipment. But as you can see down the bottom here, we've got people like spotters, and I'm sure you use spotters for things all the time. So unfortunately, these sorts of people that are very close to the action are potentially being exposed to potentially high levels of crystalline silica, depending on what's in the material that they're working with. So as Julie was saying before, I think in these sorts of situations, when we've got larger sites and we've got greater, we're working outside, we've got greater distances of where the dust can potentially go. I mean, dust suppression and the use of water is vital. So I mean, obviously we want to look at those higher end controls. We want to look at computer operated machinery. We want to look at the different processes on how you're doing it less dustier. So that's we want to look at those sorts of things. We also want to look at isolation of either the people or the actual locations of where the actual high risk work is happening. So we want to be really concerned about plant equipment and the actual the cabs within the actual material. So are those filters filtering out all of that dust that could potentially going into the cabs where the workers are operating? So engineering controls, we want to make sure that people are looking at all of these things, and I suppose dust suppression is a really important one, and on-tool dust suppression in particular. So you can see there's a couple of good photos here of on-tool extraction. You know, some people might say that they can't put this this type of or retrofit certain pieces of equipment. There's many ways to skin a cat, as we know. So use of on-tool dust suppression as well as water cannons and things like that are very important. And so, yeah, Julie's also already covered admin and PPE as well. So let's have another look at a roadway situation. So yeah, these are sort of some of the things that we go through when we do a risk assessment. So I'm sure you can do some of these things yourselves. You can do walkthrough surveys. You can look at the project and get historical reports and get information on what's happening on the site, what the percentage of crystalline silica is in the product or the host material that you're looking at. You want to look at those work groups that you're working with. So we call them similar exposure groups. So whether they're concrete paving, you know, other paving crews, maintenance workers, supervisors, people like that. We want to know what sort of group they're in, and that may more than likely give us a really good indication of what sort of risks and what sort of exposures or potential exposures they may have. So we want to look at all of these things when we're going through and doing our assessments, and also all of the existing controls that are happening. So yeah, this is a little busy slide, but as you can see, we've got our SEGs or similar exposure groups on the left there, and then that sort of looks at what sort of controls are in place and potential on the estimation of whether they're being exposed or not. So I think these are really good sort of tools to then look at your work flow and work situation, so that you can see what sort of risks some of the workers are being exposed to, depending on where they are on the site and what they're particularly doing. So yeah, I think it's a really good tool to use, I'm sure, which you can do. So yeah, again, with controls, we've gone through a lot of these already, but I mean, essentially we're going to isolate the area. We want to make sure that you know, if areas can be enclosed, then they should be enclosed. Obviously, isolation barriers, you know, danger tape, things like that needs to be put in place. Looking at HVAC sort of situations is also a potential issue or a need to be looked at. You can see there's a bitumen situation here where we've got actual on-tool extraction, dust extraction straight from the tool. So I mean, that's a really ideal sort of situation there. And then, as we mentioned before, around dust suppression and water misting, and very important that water misting needs to be targeted to the actual material. So we need the material to be damp and that sort of stuff through dampening using water. But I mean, a hose is not going to cut it. We've got to use targeted misting, targeted type dust suppression, so that those fine mist particles essentially can knock the respirable dust particles out of the air and then drop them to the ground. So what we want to try and make sure that I suppose the control is happening from the source. So the longer the actual time it is from the actual source of where it's not being controlled, the harder it is to control those dust clouds on excavation type sites. So, as we said before, it's the dust that we don't see is what we're really concerned about. So yeah, so very important that you go through and do your risk assessments, and then if needed, air monitoring, and then and also very important as well is your PPE and RPE. So as we said before about exposure standard, yeah, we need to make sure that all of these controls are looked at simultaneously. All right, so I just want to have a quick look at this slide here. So as you can see, respirator fit testing. I'm sure a lot of you have heard about it. It's coming much more into the fore now, and I think it's a vital part of risk assessment and what we're doing now, protecting our workers. As you can see on the right there, there's a human hair. And all of those white fine particles are respirable crystalline silica particles. So if you've got a bit of facial hair, stubble, or a small beard, for instance, then those particles are going to bypass your mask if you're wearing a tight-fitting respirator. So we need to make sure that you're being adequately protected. How do we do that? through respirator fit testing. So we want to make sure that yes, of course you're clean shaven, but when we do respirator fit testing, we want to make sure that that we assess the actual particular mask that you've been issued, or the mask that you're wearing has that specific tight fitting fit on your particular face. And we've all got different shapes and sizes of noggins, as you know, and so we need to make sure that that mask that you're wearing is actually protecting you. So there's qualitative and quantitative ways to do fit testing, which we haven't sort of got too much time to go into now. But I cannot recommend highly enough to get fit tested for the mask that you're wearing on site. All right, well, let's jump into our next poll. So we're going to have another poll jumping onto the screen there. So it's just going to test a little bit of your knowledge and see whether or not where you're sitting at the moment. So the next poll is: are you at risk of RCS exposure, or respirable crystalline silica exposure? Okay, so if you want to jump onto the poll there, which is up on the screen, and answer whether or not, there's 3 different or 4 different scenarios there, sorry. So there's yes, it's under control, we've identified and done all our risk assessments and have crystalline silica has a control statement in place. That's yes. Yes, action is needed. We need to look at this in more detail. And then no, this webinar has confirmed RCS isn't relevant in my organisation. And then unsure is I need further information to confirm. So let's see how we're tracking there in the chat. I think we're just about there. You reckon, Julie? I think so. I mean, it's a little bit of a spread there, but looks like there is a majority of yes there, that people are doing those risk assessments. People have got those situations under control, so that's good. And I suppose there's the next sort of big percentage section there is action is needed. So I think that's what we're seeing a lot, particularly in the situation now. We've got the dropping of the exposure standard, and so people need to reassess their controls. And then there's a few still unsure there. So I'm sure we can. The CCF and Greencap could potentially help you guys and girls out. All right. Well, I'll just finalise this situation and just sort of tie it up with a few consolidated learnings and takeaways. So as you can see, and you've heard today, these risks are wide ranging and they're across all the different industries that we're working. It's not just engineered stone. It's in all of these other areas. So construction, manufacturing, quarrying, tunnelling, all of these situations. It's very prevalent. So, we really need to be aware of our legal and legislative obligations, as James has been telling us all about now. So I think we've really got to be up to speed with those things and understand what that means on site. So what actions are needed? So I suppose we want you to risk assess these situations. We want to protect your workers. We want you to look at your controls in greater detail, and if they need tweaking, then tweak them. And if you need assistance with risk assessment or air monitoring or further guidance, then there's people like ourselves out there to assist. And I suppose there's a lot of industry trends and things like that now, but I suppose essentially, there's obviously the exposure standard dropping, but also state regulators are being much more diligent and more concerned about worker health in this space now, and rightly so. So I think we've got to be concerned about that and aware of that situation. So. All right, well, I think that's basically it for the presentation. We've got this slide here, but Jeff, you want to mention?
Yes, thank you. Thank you, James and Julie. That's a bit of a confronting sort of presentation you've made there. There'll be a lot of organisations who are either not sure whether they're impacted or have realised they perhaps are impacted. At this stage, I draw everyone's attention to the slide that's currently up with a QR code. That's a QR code which will take you to the Greencap website, where there's a lot of extra information available for you, and also details the Civil Contractors Federation 10% offer. which is 10% off Greencap services for specified areas. It's probably worth taking care of. I'd also draw your attention to the CCF website, where there's an existing offer of 1 hour's free consultation and also an opportunity to get some respirator face mask fitting. Obviously, I'm not going to pass the respirator face test.
Certainly not, Jeff.
So I don't have to go into dangerous areas. Not a strategy that everyone should adopt, but it's mine. Well, thank you very much, James, Jason and Julie. It's been absolutely informative. And now I'd like to move to the questions that we've generated during the presentation. From Andrew, does the silica 0.05 milligrams per cubic metre take into account time exposed? 1 minute versus 60 minutes, say.
Just on that, Jeff, I just also wanted to call out, Andrew, yeah, it was great pickup, mate. Should have mentioned that on the outset, that it is a time-weighted average. But it's also important to recognise that if yourself or some of your colleagues are doing longer shifts, so 10 or 12-hour shifts, that exposure standard actually drops down just to reflect that longer shift. So you're being exposed for a longer period of time. So although it's 0.05 for an 8-hour shift, for a 10-hour shift, it may be 0.036. Am I right, Julie and Jason? Somewhere around there.
Yep,
But, yeah, just
around that,
important.
yes.
Yeah, important to call that out.
I think what we've just seen there is the cooperation between WorkSafe and Greencap. WorkSafe is the regulator, Greencap is the problem solver.
One thing I want to mention, oh, is it okay, Jeff? I was thinking about the what our regulator back in Canada said, if you see visible emissions of dust, you're exceeding the exposure standard probably when you're doing any work with silica. So if you see visible emissions of dust, you're exceeding this, you can pretty much guarantee you're exceeding the exposure standard. It's very easily done.
That's a useful rule of thumb, and I think everyone who's watching at the moment has worked in a dusty environment at one time or another, and probably needs to think back and think, was there crystalline silica involved in that dust? Next question is recycled sand the same as crystalline silica? Recycled sand, recycled glass, I think that should be.
Oh, okay.
And I think there's a growing trend to use recycled glass in road aggregate, in pod bedding and other things like that.
It's also used a lot in rail infrastructure scenarios. And yeah, it's a really good way to, I suppose, reduce the risk associated with respirable crystalline silica, because we're eliminating it. We don't need it anymore. And we are hitting that hierarchy of control. We're hitting the very top. So that's a really good call out there, Jeff. We can use recycled glass.
Excellent. And I think this question's already been answered. If I have a dusty site, is it likely to be silica? Julia would say yes. When I'm cutting concrete, how do I avoid breathing dust?
You hold your breath? No. It depends on what kind of...
No, it's a very short time period.
You know what? I did a lot of work with people that were working on cement pipes back in Canada. You can't, it's hard to use a dust capturing tool for something like that. So there's no one answer. It's going to depend on what you're cutting, how long you're cutting, where you're cutting. That's part of the risk assessment, but there's so many different options out there now, whether, we're talking about pipe cutters so that you don't even have to generate dust. Like for a cement board, that's how, back in Canada, it's like 85% of those cement boards that they have on houses. Those cement boards have 85% crystalline silica in them, and they were using chop saws and power saws. So they just went to a score and snap procedure, and that just knocked down the risk.
Right.
May I add something, Jeff?
Go for it.
That's all right. Yeah, so as Julie has mentioned, the great thing about working with silica, I mean, it's not great working with silica, but the great thing about working with silica today is there's so much technology around, and there's so many manufacturers that have come out with really good solutions to some problems that we've faced in the industry for a long time. What I wanted to say as well is we don't have to wait until we're out on site to solve an issue. So if anyone, I suppose, is making a concrete panel, for instance, sake, and we need to have a hole or have an anchor or something, while the concrete's wet, insert that anchor or insert a divider in there, just so we can actually avoid processing it later on down the track. So let's just turn our minds to it in the design phase so we can eliminate that risk later on. Yeah.
Yeah, working smarter is essentially what you're saying, James, and step back and look at the situation in detail. Yeah, no, absolutely. And I suppose just finally to finalise that question, I mean, if you're unsure of people whether they're exposed or not, then as a precaution, they should be wearing RPE or a respirator or a dust mask until you can confirm whether or not they're being exposed. So worker health is paramount.
So safety and design is the bylaw. The next question is, I build pipelines. How will I be exposed to silica?
I suppose the obvious answers would be, what are you laying this pipeline in? So what are you digging out to install this pipeline? As Julie mentioned before, those workers back in the 1800s, I think it was, in Sydney, working through sandstone. Unfortunately, we don't have too much of that down here in Melbourne. But yeah, perfect example, 75% silica, crystalline silica. That's one way you could be exposed. If there's some sort of grout or some sort of cement that you use to sort of bind these pipes together, that would most likely contain crystalline silica. If you're having to make alterations to drill through, to cut through that concrete pipeline, again, you're being exposed in those circumstances as well. So there's a number of exposure routes, I suppose you can say.
So building pipelines in the Wimmera Mallee would be a dangerous activity.
Of course, as if it wasn't dangerous enough.
Exactly. From Trevor Selleck, how do we go in the agricultural sector working with sandy loam soils? Would the dust from cultivation be likely to be respirable?
Yeah, I mean,
Definitely,
yeah. No, there's possibility there for sure. Yeah. So
the suggested answer here is you can get it tested to see if there's silica. But I can't imagine many farmers on a daily basis going out to get their soil tested.
Yeah, that's
I
right.
could be wrong.
And it's going to vary too, right? It's not like it's going to be a consistent makeup, maybe throughout the area that they're working on. Gosh, one of the first jobs I did with silica, they were just getting rid of dust from cracks, so they could do crack seal on the road, and that was causing them to exceed their exposure. So just, it's very easy, but can't tell without looking at their procedures and what they're working on, and maybe do some atmospheric sampling.
Fair enough. I see a comment here, which is interesting. Glad I don't have to stop going to the beach, though. It's a bit scary.
Yeah, I know exactly. That's what gets people. I actually have a picture of sand. I think it's at the end of the slide, Jason, if you want to go a couple, just to show the difference, if you want to skip through.
Sorry,
We've
guys.
got like 3 hours of material we had to get through in 15 minutes. So sorry, we had to cut some things out.
So dust from Yvette, dust in crushed rock. Could truck drivers loading likely to be hitting the exposure limits?
Do you see some visible emissions of dust from them moving that crushed rock, Yvette? If so, then yes.
Are there windows down? Are they are the filters within the truck drivers
stay inside? Sorry, if the truck drivers are leaving, if they're in those enclosed cabs with filtered air, great. But those enclosed cabs are great, and they have them on excavators, right? And they have purified air, filtered air, etc. But generally when we get to site, the workers have got the windows rolled down, the doors open because of communication issues, right? So we have to think of, in theory, they're fantastic, but sometimes they need a bit of modification.
There's a point there, Julie. You brought up a really good point. I know I'm sort of going away from the truck driver scenario, but it does bring us to a really good point around housekeeping. So particularly in excavators, this excavator operator, they get in and out, they go to smoker, they go to lunch, they go, have a dart off site somewhere, something like that. They're getting in and out of the cab all the time, and they're bringing in a lot of dust when they're getting in and out of that cab. For some reason or another, the recirculation vent in a excavator is at the foot level. So as you generate dust, as you operate the controls, the dust is getting recirculated in, and where does it get spat out? It gets spat out in the breathing zone. It's a funny old design, but it's just really it's a really good reminder to see if you can put a HEPA filter on your recirculation vents. That's one way to sort of eliminate that. But you can also have a look at housekeeping practices. So you can get yourself a vacuum and M-class vacuum and just vacuum out your cab. Just make sure you have a nice tidy cab. You're not stirring up that dust, or you're reducing the amount of dust that you're stirring up, which is great. Julie, you got something to say?
Just sorry, yeah, what the cleanup job is usually the dustiest part of the job, right? I went to one site, they took a leaf blower to
Yep.
clean underneath the cabinetry, and that there was dust everywhere. So that, you know, it was good all day, and then at the end it
No blowers, no compressed
no
air,
compressed air.
please.
Sorry, I know you
All
probably
right,
want to wind it down, don't you, Jeff?
Yeah.
Thank you,
No.
everyone. We've probably reached the end of our time here, but I will reference a conversation that I've had with James, and that is that the person most likely on site to be affected by silicosis is probably the person who's got the broom and sweeping up the dust. So don't overlook that. Well, thank you, everyone. That's been an extraordinarily good presentation. I think there's been a lot of information there for our members, and hopefully they will now take action on it. Refer you again to the QR code. That QR code will take you to the Greencap website, where you'll see documents from both Greencap and WorkSafe, which you can access, and I'd recommend that. Going forward, Greencap are always available there to provide you advice, so if you need some clarification of something like that, feel free to give them a call. So that's the end of our presentation today. So thank you, everyone, for being here. And I've just mentioned the following CCF events coming up. We have the CCF Regional Forum in Bendigo on August the 18th, the CCF Regional Forum in Shepparton taking place on the 19th, and the Earth Awards. Don't forget the Earth Awards. They'll be taking place on August the 26th. And this year we've had some spectacular projects. Quite looking forward to the gold level event that'll be that night. So thank you very much, and don't forget to check the QR code. Thank you.
Thank you.
Thanks, Jeff. Thanks all.